In today's class, we're going to continue the discussion on chain rule. We'll solve few problems on chain rules, and afterwards we'll discuss about the derivatives of a implicit function. Now, the first problem which we had is find the first order partial derivatives of the function z equal to phi of x plus 80 and psi of x minus 80. That means your phi is a function of the variable x plus 80 and psi is a function of the variable x minus 80. Now let us do one thing. Let us call this variable x plus 80 as u and x minus 80 as v. Then this z becomes phi of u plus psi of v. Now see, your u is x plus 80, therefore your u is a function of x and t, and v is a function of x and t. Whenever x changes, the rate of change of x results in rate of change of u as well as v, and whenever u and v changes, correspondingly z also changes. That means your x and t are the independent variables, and depending on x and t, your u and v changes. Whenever u and v changes, your phi z also changes, because z is phi of u plus psi of v. That means here we are having only two independent variables, that is x and t. So you have to find what is your rate of change of z with respect to x and what is rate of change of z with respect to t. That means because you are having two variables, you have to differentiate partially by taking one variable at a time. That is, first you have to find dou z by dou x. Similarly, you have to find dou z by dou t. But remember, your z is a function of u and v, and u and v are in turn functions of x and t. So straight away you cannot differentiate z with respect to x. So you have to differentiate z with respect to u and v, because there are two variables. You have to partially differentiate z with respect to u by taking v as constant, right? Then partially differentiate u with respect to x. Similarly, partially differentiate z with respect to v, then partially differentiate v with respect to x. Like that you have to do. Anyhow, we need partial derivatives. So let us differentiate this equation 1 with respect to x and t. When you are differentiating with respect to x, your t is constant. Similarly, when you are differentiating with respect to t, your x will be constant. So let us differentiate u partially with respect to x. That is dou u by dou x equal to derivative of x is 1 plus derivative of 80 is 0, because this is a constant. Similarly, dou u by dou t is equal to derivative of x is 0, because it's a constant, plus a is constant, will keep as it is, into derivative of t is 1. So a into 1 is a. Now similarly, what is the derivative of v with respect to x? Dou v by dou x equal to derivative of x is 1 minus derivative of 80 is 0. So simply you will get 1. Similarly, dou v by dou t is equal to derivative of x is 0, minus a is constant, because it is product, I'll keep minus a as it is. Then what is the derivative of t? 1. 1 into minus a is minus a. So that is your dou v by dou t. Now we have assumed u as x plus 80 and v as x minus 80. Therefore your z becomes z equal to phi of u plus psi of v. So your z is a function of u and v. So let us partially differentiate z with respect to u and v. When you partially differentiate z with respect to u, remember your v is constant. When you partially differentiate with respect to v, your u is constant. And remember, your phi is a function containing only variable u, and psi is a function in terms of v only. Now let us differentiate z with respect to u. dou z by dou u equal to derivative of phi of u is phi dash, because this is a variable function in u, into dou u by dou u. Derivative of u with respect to u is 1. So simply phi dash of u plus derivative of psi, because this contains only variables. I mean, this contains a equation in terms of v. Whole of that equation is constant. Therefore, derivative of a constant is 0. Similarly, dou z by dou v is equal to, this one contains only function of u, which is a constant. Therefore, derivative of this is 0, plus derivative of psi is psi dash of v. Now, afterwards, let us find the first order derivatives. How? Your z is a function of u and v. Let me copy down this itself. Z is a function of u and v. Z is a function of u and v. And your u and v are functions of x as well as t. Now, first, we'll do one thing. We'll keep t as constant and we'll vary only x. Whenever there is a rate of change in x, your u and v also changes, because u is x plus at, v is x minus at. When the value of x changes, the value of u also changes, v also changes. When the value of u and v changes, your z also changes, because z is phi of u plus psi of v. So that also changes. So that's the reason. Let us find out what is your dou z by dou x. What is your dou z by dou x? Very simple. Dou z by dou x equal to, right, dou z by dou u into dou u by dou x. Dou z by dou u into dou u by dou x plus dou z by dou v into dou v by dou x. That's the second term, right? Similarly, now let us find out what is your okay. Let us consider partial derivative of this with respect to t. Whenever there is a rate of change in t, z also changes. Why? Because whenever t changes, u value also changes, v also changes, therefore z also changes. Now that's why we have to find dou z by dou t. What is your dou z by dou t? It is dou z by dou u into dou u by dou t. That is your first term, plus dou z by dou v, dou z by dou v into dou v by dou t. That is another term, second term. Will you agree? Now from the above, we are having derivatives dou u by dou x, dou u by dou t, dou v by dou x, dou v by dou t, dou z by dou u, dou z by dou v. Substitute all of them, you'll get this much. But remember, you have to find the answer in terms of independent variable x and t. So substitute back what is your u and v. Your u is x plus at, v is x minus at, and simplify, you'll get this much. Now let us see one more problem. Find the first order partial derivatives of the function phi, which is dependent on x and y, and x and y, which are dependent on u and v. All right. Your phi is a function of x and y, right? And your x and y are functions of u and v. So whenever there is a change in u and v, there will be a change in x and y, hence in turn in phi. Therefore, u and v are the independent variables. So you have to partially differentiate phi with respect to u and phi with respect to v. For that, let us find out what is the derivative of phi with respect to x. When you are differentiating with respect to x, your y should be treated as constant in this. So dou phi by dou x equal to derivative of x square is 2x. Similarly, dou phi by dou y is equal to derivative of y square is 2y, because derivative of x square is 0. When you are finding the rate of change with respect to y. Now we are differentiate phi with respect to x and y. Now let us consider x and y. What is your x? U minus v. And what is your y? U plus v. Now partially differentiate these two with respect to u and v. Why you have to apply partial derivative? Because these two are functions in two variables. If it is only one variable, I would have applied the total derivative d by, right? Now, what is your dou x by dou u? When you are differentiating with respect to u, your v is constant. So derivative of this is 0, derivative of u is 1. So dou x by dou u is 1. What is your dou x by dou v? Derivative of u is 0, derivative of v is 1 with minus sign. Similarly, differentiate y with respect to u. So you'll get dou y by dou u, which is equal to derivative of u is 1, derivative of v is 0. Similarly, what is dou y by dou v? Derivative of u is 0, derivative of v is 1. So we get this. Now, see, we have to find the derivatives. Am I right? So let us write. Your phi is a function of x and y, and your x and y are functions in u also. We'll keep v constant. Whenever there is a rate of change in u, x and y both changes, because x is u minus v, y is u plus v. If there is a change in the value in u, there will be a change in x value as well as y value. Whenever x and y changes, your phi also changes, because your phi is x square plus y square. Phi is x square plus y square. So let us find what is your dou phi by dou u. So your dou phi by dou u is equal to dou phi by dou x into dou x by dou u plus dou phi by dou y into dou y by dou u. That is your required answer, right? Similarly, what is the derivative of, let us see another one. We know that whenever there is a change in v, your xy also changes, because x is u minus v and y is u plus v. If there is a change in the value in v, there will be a change in the answer in x and y also. Hence, there is a change in the value of phi also. So what is your dou phi by dou v? It is dou phi by dou x into dou x by dou v plus dou phi by dou y into dou y by dou v. That is your second term. You know what is the derivative of all these, right? Substitute these in the corresponding fields. You'll get 2 into x plus y and 2 into x minus y. But remember, here your independent variables are u and v. So we are expecting the answer in terms of u and v only. So substitute what is your x and what is your y. Your x is u minus v and y is u plus v. So you'll get 2u into 2, which is 4u. Similarly, 2 into x is u minus v and y is u plus v. Minus of this will be minus u minus v. So minus u minus plus u cancels. Minus v is minus 2v into 2, which is minus 4v. We got the answer. Now, in the similar fashion, we have to find the first order partial derivatives of the function f, which is dependent on x, y, and z. X, y, z. And x, y, z are dependent on u, v, w. 3 variables. U, v, w. Is that right? So here independent variables are u, v, w. So you have to find partial derivative of f with respect to u. How are you going to find partial derivative of f with respect to u? Yes, f by dou x, dou f by dou u is equal to dou f by dou x into dou x by dou u plus dou f by dou y into dou y by dou u plus dou f by dou z into dou z by dou u. Because of your f is a function involving 3 variables, you will get like this. Similarly, what is the partial derivative of f with respect to v? dou f by dou x into dou x by dou v plus dou f by dou y into dou y by dou v plus dou f by dou z into dou z by dou v. Similarly, what is the partial derivative of f with respect to w? You'll get dou f by dou x into dou x by dou w plus dou f by dou y into dou y by dou w plus dou f by dou z into dou z by dou w. For finding that answer, you have to differentiate f with respect to x, y, z partially. When you are differentiating with respect to one variable, you have to keep the other two as constants. Keeping in that mind, you differentiate, you find out what is your dou f by dou x, dou f by dou y, dou f by dou z. Similarly, your x, y, z are functions of three variables u, v, w. So you have to differentiate x with respect to u, x with respect to v, x with respect to w by keeping the two variables as constant and differentiating with respect to only one variable. After finding the partial differentiation of all these, substitute in them and bring the answer in terms of independent variables u, v, w. So you'll get this much, but you have to substitute what is your y, z from this x, y, z. Substitute and bring it to equation involving only u, v, w. Do that for all of them, right? You'll get the required answer. I've given few problems. Here, x, y, f is a function of x and y, but x and y are functions of r and theta. So your f is a function of x and y, but x and y are functions of r and theta. Therefore, what are independent variables? R and theta. So you have to find dou f by dou r and dou f by dou theta. Similarly here, f of u comma v. So your f is a function of u and v. But u and v are functions of x, y, z, three variables. X, y, z, right? So you have to find dou f by dou x, dou f by dou y, dou f by dou z. What is your dou f by dou x? Dou f by dou u into dou u by dou x plus dou f by dou v into dou v by dou x. That is your dou f by dou x. Similarly, you have to apply for all of them. And the last one, your phi is a function of x, y, z. Your phi is a function of x, y, z. And your x, y, z are functions of u and v. So you have to find dou phi by dou u and dou phi by dou v. How you are going to find dou phi by dou u? It is dou phi by dou x into dou x by dou u plus dou phi by dou y into dou y by dou u plus dou phi by dou z into dou z by dou u. That gives you first one. Similarly for second one. So find all these things. Now let us move on to next topic. That is derivative of an implicit function. Suppose there is a continuously differentiable function f of x comma y is equal to some constant. And also your y is dependent on x. Y is dependent on x. And let us assume this is an implicit function. This is an implicit function. Then how to obtain the derivative of this implicit function? You know what is meant by implicit function? Implicit function where you cannot express one variable as in terms of other. Here, see here, x and y are mixed together. You cannot separate them. Such functions are called as implicit functions. Now, because your y is dependent on x, your f is a function involving only variable, that is independent variable x, that is f, which is a function of x and y. But your x and y both are dependent on x only. So you can find partial derivative with respect to x. That's it. So what is your partial derivative of f with respect to x? That is dou f by dou x. Am I right? Yes. Partially differentiate this by chain rule. Dou f by dou x plus dou f by dou x, dou f by dou x, right? into dou x by dou x is 1. So dou f by dou x, that is what remaining, plus dou f by dou y into derivative of y with respect to x. Because your y is dependent on x, only one variable, so you will get total derivative, not the partial derivative. We apply partial derivative if there are more than one variable is there. But here only one variable is there. So you'll get dou f by dou y into dy by dx is equal to derivative of constant is 0. But actually we are expecting dy by dx. Therefore, send this dou f by dou x to this side. That becomes minus dou f by dou x divided by, send this one to denominator. That becomes dou f by dou y. So we got dy by dx. This is the formula for finding the derivative of an implicit function. Right? You have to differentiate the given, you have to call the given function as f of xy, differentiate that partially with respect to x and y, substitute in this. That's it. Now, let us see the first problem. Find dy by dx at 1, minus 1, where x cube y cube 2x plus 2x square y plus 3x to the power of 4 minus 1 equal to 1 using partial differentiation. Send this one to this side. Then that becomes x cube y cube plus 2x square y plus 3x to the power of 4 minus 2. Call that one as f of xy. So your f of xy is equal to 0. Now differentiate this partially with respect to x. As usual, when you are differentiating with respect to x, your y should be treated as constant. So x cube, derivative of x cube is 3x square, y cube is constant, plus 2y is constant, derivative of x square is 2x, 2 into 2, 4xy, plus 3 is constant, derivative of x to the power of 4 is 4x cube, so 4 into 3, 12x cube. Similarly, partially differentiate f with respect to y, dou f by dou y is equal to, when you are differentiating with respect to y, your x is constant, so x cube is constant, derivative of y cube is 3y square, so you'll get 3x cube y square. 2x square is constant, derivative of y is 1, plus derivative of these two, they are constants because we are differentiating with respect to y. Therefore, this becomes 0. Now substitute that in this formula, dy by dx equal to minus dou f by dou x divided by dou f by dou y. Substitute it. But we want the answer at 1, 1, not minus 1, 1. This is plus 1, 1. We want at 1, 1. That means your x value is 1 and y value is 1. At that point, you want to find the slope of the tangent of the function y. Okay, let us substitute this right here. X equal to 1 and y equal to 1. You'll get minus 19 by 5. That is the slope of the tangent drawn at the point 1, 1. Okay, now I've given one more problem, dy by dx. Call this one as f of xy and differentiate with respect to x and y and substitute in the answer. That gives you dy by dx. Similarly, find dy by dx if second degree equation is given, right? Call this one as, because already f is here, so let me use some other symbol. Let us say u is equal to this. Differentiate u with respect to x and u with respect to y. You'll get this much. Substitute in the formula, dy by dx is equal to minus dou u by dou x divided by dou u by dou y. Substitute and simplify, you'll get the answer. Now, I've given few problems. You write them as assignment. You solve by the same method which we have used earlier, right? I'll stop at this stage. Thank you.